Welcome to ePathshala PG courses on computer science. Today we will see about a different module called JDBC. The first module deals with the introduction of the JDBC. The objective of this module is to introduce about JDBC API. We will also know about the architecture of JDBC and we will understand the design of the JDBC API. So, when we take the design of the JDBC API, we will try to know about the different classes and the different methods what we have in the API. So, JDBC it basically stands for Java Database Connectivity. It is used for accessing databases from Java applications, and we know that Java is a very standardized programming language, but there are many versions of databases, SQL databases available. So, we need to have a way to make this JDBC or this Java application program talk to the database. So, let us see about how this Java supports for JDBC. So, JDBC we know that it is for accessing any databases. It is a Java methodology supported for accessing the databases. We know that the Java is a standardized programming language. So, programs would be developed with Java or JDBC which would be normally platform independent or vendor independent. So, the basic functionality or the basic feature of Java or JDBC is that it supports platform independence and vendor independence. We know that when we write a Java application, it is a write once, compile once, but we can run anywhere. So, if you have the JVM available, we can execute our Java class code. So, this JDBC provides a standard API for developers, Java developers, to make it possible to write database applications and then communicate with the databases. So, this is a pure JDBC is a pure Java API which would make the users communicate to the databases. So, we have support in this JDBC as JDBC driver manager and JDBC drivers. This drivers or driver managers normally provide the bridge between the database and the Java programs, the application programs. So, you would have heard about this ODBC. So, before our JDBC exists, we have a connectivity, open database connectivity, which is called as ODBC. This is to make any application, high level language program communicate with the database. So, we have open database connectivity before the existence of JDBC. So, to access any relational databases, we need to have this kind of API ODBC driver installed in our machine. So, but nowadays as a Java programmer, you would like to write a Java application and you want to connect to the database. So, Java provides JDBC, and if at all you are working with the previous versions or with the older models, then you will have an ODBC driver installed in your system. So, this JDBC can talk to the ODBC, and through ODBC you can get connected to the database. So, this can be applied as a bridge between the JDBC and the ODBC. But nowadays this ODBC is not very appropriate for direct use from the Java programming language, because this ODBC uses a C interfaces. So, JDBC purely a Java methodology. So, we will be writing Java code, application code when you want to talk to the database. But this bridge, there would be a bridge which would connect this JDBC with the ODBC. This would normally convert all the Java calls to the C or C++ function calls. So, ODBC basically uses the C interface, and there occurs a number of drawbacks like security, implementation, and in providing robustness or automatic portability. So, when you make calls from Java to native C code, it is not secure or portable. So, nowadays we have JDBC and we have different kinds of drivers, and we can make use of a driver which is actually a fourth type of driver, which is a pure Java driver, where we can make the JDBC directly talk to the database. So, now let us see about the JDBC architecture. So, as I told you, we will be writing a Java application. and within this Java application we have database statements, that is the calls you want to make write to the database or you want to access the database. So, we have a Java application using which you want to talk to the database. So, database has a different language. So, database is supported by a database language, and Java is a high level language, high level programming language. So, this database code would normally appear in a Java application, and a database can understand this database code or the database statements, but it cannot understand the other part of the code. So, you need to have some mechanism which would make this database calls which is inside our application to be converted to the database calls. So, here we have the JDBC API. So, Java code normally calls the JDBC library, and this JDBC would load a driver. So, using this driver we will be able to talk to the particular database. So, and we can have more than one driver. So, for each of the database we can have a driver. So, it is not that one single driver would support all kinds of databases. So, we can also have more than one driver for more than one database. So, and the ideal thing about this is we can actually change the database engine without changing the application code. So, once we have written the application code, this driver would help us to connect to the different database engines. So, each of the database engine may have a different driver, and this through JDBC you can connect to any of the driver and you can make an access to the database. So, this is the architecture provided to know that how a Java application would be talking to the database. As I told you, JDBC drivers are classified as 4 types by Sun. So, type 1 they call it as bridge drivers, and type 2 they call it as native drivers, type 3 they call it as middleware drivers, and type 4 is a pure Java driver. So, here this is an architecture which shows that how the JDBC is going to talk to the database through the different kinds of drivers. So, type 1 is a bridge driver. So, our JDBC, between our JDBC and ODBC there would be a bridge which would make this JDBC function call converted to an ODBC function call, and through which you can talk to the database. And type 2 is a native driver. This would normally make the functions, the Java database calls to the CLI library calls through which you can talk to the database. And type 3 is through an installation of a middleware server. So, we call this kind of driver as middleware driver, and we have a middleware server. So, this server would be one single component using which you can connect to different database drivers and through which you can connect to different database engines. And type 4 is the pure Java driver. So, nowadays we have a support for the type 4. So, anyone would be very much interested to make use of a type 3 or a type 4 driver. So, type 3 would be very useful when you want to talk to different kinds of database engines through different drivers. So, you will have a middleware server which would be one single driver which you need to get installed in your machine, through which you can talk to the different database engine. And type 4 is a pure database driver through which you can talk to the database. Here for every database engine you need to have a separate driver. So, now in detail if you can see, type 1 actually uses a bridging technology, and it requires the installation or configuration on the client machines. And nowadays this is not very good for the web, and it is a very old methodology. It is just for an experimental purpose. We nowadays use a type 1 drivers. So, when you make use of type 1 drivers, we need to create a data source name, and once our ODBC driver should be available in our machine, client machine, and we need to create a data source name and using which you can connect to the database. So, here an example of type 1 driver is an ODBC bridge. And type 2 drivers are normally called as native API drivers. This would normally convert the JDBC function calls to the C or C++ function calls. So, it is normally called as a native API drivers. So, to native function calls it gets converted, and this also requires an installation or configuration on the client machines, and it is used to support existing CLI libraries. But usually it is not thread safe, and it is mostly obsolete now. So, we can, as an example, we will know that type 2 drivers would be like Intersol Oracle driver or an WebLogic drivers, which are nowadays obsolete. And type 3 drivers, as I told you, in the architecture we saw there was a middleware server using which you can connect to the database. So, it calls as a type 3 driver, our JDBC function calls will call the middleware server, and this would be usually on the database host. And this is very flexible, and it allows multiple access to multiple databases using one single driver. So, this normally it is very useful when you have different drivers for different database engine, and you will make use of one single driver to connect to the different kinds of drivers. But the thing is that only you need to download one driver, but this also requires an installation of the server application, and you need to maintain it. So, and as an example, we know that it is Symantec and DB anywhere. And type 4 drivers is nowadays very popularly used. This is 100% pure Java. This uses Java networking libraries, so it basically makes use of Java socket programming to talk directly to the database engines. The disadvantage is that we need to download new driver for each database engine. So, some example of type 4 drivers are Oracle and MySQL. So, if you want to talk to an Oracle database, you need to have an Oracle driver. If you want to talk to a MySQL database, you need to have an MySQL driver. So, these are the different driver class names. So, as I told you, for every database engine you will have a driver using which you will talk to make your Java program talk to the database or communicate with the database. So, we have different drivers for each of the database engine. So, as an Oracle, they have a driver called Oracle dot, it is identified with a name class name as Oracle dot JDBC dot driver dot Oracle driver, and MySQL would be identified with a driver class name as com dot MySQL dot JDBC dot driver, and MS SQL support has a driver class name like com dot Microsoft dot JDBC dot SQL server dot SQL server driver. So, you will be loading the different kinds of driver in order to connect to the different database engines. So, as a limitation of JDBC, we will know that JDBC does not support scrolling cursors, you cannot go and back. So, once you start from the beginning, you have to keep reading the next data, and you cannot have bookmarks. So, a database can be accessed sequentially using this JDBC. So, the support for JDBC in Java is through a package called java.sql. So, we have specifically all the entire JDBC API is available within the package called java.sql. So, we have different classes and methods that are available within this package java.sql package sql.star. In order to make use of the different classes and methods from the package, you have to import this package. So, the first line of your JDBC program would contain this statement, you have to import the java.sql.star. Now, as I told you, your Java program, it is a JDBC program, has to directly connect to the database. So, if it has to connect to the database, the host function calls has to be converted to the database function calls. So, what you need to do is we need to load a driver. So, either you can load a driver directly, or you can have a driver manager to load and register the driver. So, if you opt for loading a driver directly, then you can you have a class called driver class, and there is another class called driver manager class. So, you can directly use a driver class and load the driver, and once you get a driver object, you can make use of a method called connect method to create the connection object. So, this connection object is the one through which you are making the database connection in order to make access to the database. And probably this is not recommended. Instead, we will be normally using another class called driver manager. So, this would be useful if you want to know that you are actually using a particular driver for every database. So, now coming to this driver manager, we need this driver manager because this is actually managing the different kinds of driver. So, you can directly talk to the driver manager or application talk to the driver manager. This driver manager would be useful for managing the different drivers that are available in our machine. So, this driver manager would when you start communicating with the driver manager, this driver manager would try all the drivers and it uses the first one that works. So, when a driver class is first loaded, it registers itself with the driver manager. So, instead of directly loading it, you can load the driver class and this has to get registered with the driver manager. So, the driver manager would be aware of the different drivers available in the client machine. So, therefore, to register a driver, we have to load it. Now, the next step what we have to do is we have to register a driver. So, to statically load the driver, one thing is that you can statically load the driver as we have seen in the previous slide, or dynamically you can load it and register it with the driver manager. So, Java provides a method called forName to dynamically load the driver. So, it is in the class use class.forName and you will be loading the driver. So, assuming that this is your driver name, so that this driver name class name would change for the different drivers. So, you will give the driver name and you will dynamically load the driver. So, when it is loaded, it automatically gets registered with the driver manager. So, once it gets registered with the driver manager, we can use a method called getConnection. So, driver manager dot getConnection would return a connection object. So, this is a statement you will be using it. So, class dot forName to load the driver, and the next statement you have to make use of the method called getConnection with the driver manager in order to create the connection object. Or we can also use the JDBC driver and then you can load it. So, the different object classes supported in JDBC in order to support for a Java application access the database, we have different kinds of classes like driver manager. This actually loads and chooses the drivers. Loads the driver and chooses the driver whichever one is first identified by the driver manager. And driver would be necessary through which you will connect to the actual database. And we need a class called connection class, using which we can have a series of SQL statements executed to and from the database. And statement is another class using which you can execute a single SQL statement. And there is a class called result set, and the records that are returned from executing a statement would be stored as a result set. So, these are the important classes in JDBC to support for writing a JDBC application. So, we need to know about a class called driver manager, we need to know about a class called driver, then there is a class called connection, there is a class called statement, and there is another class called result set. Now, coming to the JDBC URLs. So, once you load the driver, we need to connect to the JDBC URL or the URL of the database. So, we call it as a JDBC URL, the place where you have your database. So, this would be the JDBC URL would contain three components. So, it starts with JDBC, then you will have a colon, then you will have a sub protocol, then a colon, and then the source name. So, here each driver has its own sub protocol. So, it differs for each of the driver, and each sub protocol will also have its own syntax for the source. The source is the data source name. So, supposing you want to connect to MS Access, you will be using like JDBC colon ODBC, and then you can give the data source. So, as an example, your JDBC URL can look like this: JDBC colon, and it is a bridge ODBC, then colon, and then this is the data source name, the database data source name which would be created using the ODBC. And now the next this is a URL which supports for connecting to MySQL. So, here you can see that it starts with JDBC, and this is a sub protocol. So, the sub protocol is MySQL, it starts with MySQL colon, and then the host would be given, then the port is optional, and this is the sub protocol. It varies for different drivers. So, MySQL makes use of a sub protocol with this format, and then you will give the database name. As an example, we can see here JDBC colon, then you will have MySQL, then this is the host name, and this is the port number, and this is the data source name. The next step what you have to do is, once you load your driver and your driver is registered with the driver manager, you need to create a connection object. So, a connection object would be created using the get connection method in the driver manager class. So, driver manager dot get connection would give you a connection object. So, this get connection can take URL, or it can take 3 parameters like URL, the username and the password. So, this would connect to the JDBC URL with the given username and the password. So, either you can get the connection by giving the URL, JDBC URL, or you can give the URL, username as well as the password. So, this get connection method actually throws an SQL exception and it returns a connection object. And what is actually meant by a connection? So, you need to have a connection to talk to the specific database. So, any connection would represent a session. So, within this context of the session, this SQL statements would be executed and the results are returned. And it is that we can also have multiple connections to the database. Any connection can also provide the metadata information about the database, tables and the fields, and it also provides methods to deal with transactions. So, once you load the driver, register the driver, we need to have a connection object using which we will have an established session within which you will be executing the SQL statements in the database. And now, this is what I told you, the 2 steps what you actually need to make your JDBC talk to your database. So, we need to load the driver. So, we use class.forName and this is the driver. So, the driver is going to be sun.jdbc.odbc.jdbc driver, and the connection object would be created by the method called get connection, and you need to give the JDBC URL here. So, the URL is a string, that is jdbc:odbc::jnf, and this can actually throw an exception called class not found exception or an SQL exception. And coming to the different methods, once you create a connection, the different connection methods are there like create statement, prepare statement, and then there is another method called prepare call. So, you can have different kinds of statement objects created once you create a connection. So, it can be a statement, or it can be a prepared statement, or it can be a callable statement. So, you can use a method called create statement that would return a new statement object, and you can use a method called prepare statement that would return a new prepared statement object. So, when you use your prepare statement, you have to give the SQL statement within this prepare statement, and you can also use a method called prepare call in order to return a new callable statement object. And now this statement object is used for executing a single SQL statement and obtaining the results produced by it. And now coming to the different methods of this statement. So, we have methods like execute query, and then we have method like execute update, or we can make use of another method called execute. So, these are the 3 different methods you normally make use of with the statement object. So, as I told you, statement is an object using which you can execute a single SQL statement. So, it can be your SQL statement can be a select statement. So, if it is an select statement, you make use of a method called execute query to execute a single SQL select statement, and this would return a single result set. So, the return type of execute query is a result set, and there is a method called execute update. This actually gets the SQL statement. The SQL statement is given as a string, and SQL statements that are supported for execute update are insert, update and delete. So, only these SQL statements like insert, update and delete can be given within this execute update statement, and this normally returns an integer. This specifies, this integer denotes the number of rows that has been changed by the update statement. And there is another method called execute method. So, this is normally useful when you want to execute a single statement, you want to execute a select statement that may return multiple results. So, you can make use of an execute method and it returns the boolean value. And coming to the result set, as I told you, we have a method called execute query. This actually returns a result set. So, result set would provide access to the table of data that is generated by executing the statement. So, once you give the SQL statement, that would provide you a result set. So, your select statement of your SQL would give a set of records, table of rows which is now processed or accessed by the result set, and only one result set per statement can be opened at a time, and the table rows are normally retrieved in sequence, and a result set would maintain a cursor which would point to the current row of the data, and you will be able to read record by record from the result set. And in order to move the cursor in the result set, we have a method called next method that moves the cursor to the next row. And now coming to the different methods that are supported in the result set. So, result set would provide you a table of set of rows, and you have a cursor using which you can process every row from the result set, every record or every row from the result set. So, there is a method called next method. This would activate the next row, and this next method, the first call to the next method would actually activate the first row, and this would return to a boolean value. So, it can be a true or false value, and a false would be normally written if there are no more rows. So, it keeps the cursor reading record by record, and once all the records are read, this next method would return a false value. And there is a method called close. So, this would actually to close the result set, and normally we need to close it so that it allows to reuse the statement that created it, and automatically this is called by most statement methods. So, normally once you create a statement, we will be normally would be interested in closing it. And the different methods in the result set are like get type which takes the column index, and get type which takes the column name. So, the column index would normally starts from 1, and it is not like an array. So, the first field would be with the column index 1, second field will be the column index 2. So, get type varies with the type of the column. So, it can be a string type or it can be an integer. Different 8 types of data types supported in Java can be given in this type string. And there is another method called find column. So, if you give the column name, you can find out the index. So, these are some of the methods in the result set. So, as I told you, there are methods like get type. So, the type varies depending upon the different the 8 primitive types supported in Java are given here. You can see here, it is get string, get boolean. If the column name is a byte, get short, get int, get long, get float, and then get double. And to support for date and timestamp, we have 3 different methods like get date, get time, and then get timestamp. And in SQL, we have null. Null means the field is empty. So, you cannot treat it as 0 or a blank. So, it is field is empty. You doesn't know that what value you have to insert it there. So, here in JDBC, you must explicitly ask if a field is null. So, you have to use a method called isNull in order to check whether the field has a null value. This method is also available in the result set. So, you will use it as result set dot isColumn isNull and give the column name. As a summary, this module we have actually introduced about the JDBC API. We have seen the different drivers supported in order to make JDBC communicate with the different database engines. We have discussed about the architecture, JDBC architecture, and we have also understood the design of the JDBC API, the different classes and the methods that are used in them. Thank you.